A complex fraction is a fraction that contains an additional fraction in either the numerator and/or the denominator. To simplify a complex fraction, we first need to make sure that we only have a single fraction in the numerator and/or denominator. In this case, I have a subtraction of two fractions in the numerator and in the denominator. So I first need to simplify my two fractions into one. I'm going to do this first by focusing just on the numerator. I see that the least common denominator between x and y is the product xy. So just using our basic arithmetic, I realize that in order to get xy at the bottom, I need to multiply top and bottom of this fraction by y. For the other fraction, I have a y in the bottom, so I need to multiply this side by x, and again, equivalent fractions, I must multiply top and bottom by x. So now I'm going to simplify this over to the right, and I have 2y minus 3x over the common denominator of xy. Now I'm going to focus on the denominator. In this case, the LCD is also xy. So again, on the first fraction, I need a y in the denominator, so I must multiply top and bottom by the same number. So this gets me 4y over xy. And on the other side, I multiply top and bottom by x, and I get minus 5x all over the common denominator of xy. So now that I have a single fraction in the numerator and denominator, I can go ahead and simplify this. In one method, I'm going to break this up and do it one step at a time, which means I'm going to take the numerator and I'm going to rewrite it, because a fraction is simply a division problem. So I'm going to now divide by the denominator. So when you divide by a fraction, you are multiplying by the reciprocal of that fraction. So we're going to flip this upside down. We have xy on the top. We have 4y minus 5x on the bottom. So now I'm going to pre-reduce. I see that I have a product of xy in the numerator here, which leaves me at 1. Product of the xy here, which leaves me 1. Nothing else can be reduced. So my final answer in this particular case is 2y minus 3x over 4y minus 5x. I will now multiply the complex fraction using the second method that has been demonstrated. When I have the same denominator in the numerator and denominator, I can basically multiply this as one giant fraction. So that means I'm going to multiply top and bottom by the same number. So in this case, I'm going to multiply xy over 1 as one number over itself, xy over 1. By doing that, I can see that I'm going to reduce these xy's here, here, and here. And that leaves me with 2y minus 3x over 1, so I can simply write 2y minus 3x. And that leaves me 4y minus 5x over 1. And so my answer is still 2y minus 3x over 4y minus 5x.